Good evening, and welcome back to Vegas October 1 Sounds. Last night we left off with using an online tool at noisetools.net. It's called the Noise Map, and I had a very simplistic um, set of models to show you how to use the basic features of the program. Tonight what I'm going to do is show you what happens and what you can do when you have a little bit more complex models. So what I've got here is a basic simple model of some of the major features of Vegas surrounding the venue. And so for example, we have the Mandalay Bay, and I've got the three wings, and on the one wing of interest we've got the stub nose. Then we have the Delano, the Luxor, the Excalibur, and part of the Tropicana, along with the fountain area out in front of the Mandalay Bay, the part of the wall along the boulevard. We got the six little VIP things, and we got part of the wall on the back side. And this thing's going to be another 20 minutes calculating it at fine resolution, but right now we have an 8-meter resolution, which means that this has calculated this map based on 8 meters of resolution, which is 24 feet. So you're not going to get the fine detail if you really get down into the nitty-gritty. But what I wanted to show you is how this sound map, or noise map as they call it, is used. And we can see here, well, let's tell you what I've got for the basic parameters. I'm still using a 100 meter, 300 foot elevated source of sound at 140 decibels. And I used, anyway, 140 decibels coming out the window. And that's room 135. And given that, and given a ground reflective or absorptive value of 0.3, which is not all the way reflective, but 30% of the way to absorbing stuff. With its setting at this point, it gives me an expanded soundscape so that I can see more of some of the details of where the gradients are on the sound. I've also turned off A weighting, and that gives me again a greater soundscape, or a greater propagating range for the louder sounds. And so, once this gets all done calculated, we can use it right now as it is, and we can see that fundamentally, if you look at this from a first order approximation to something, you can see that the source of sound being right here, the red area, casts shadows just like the sun does on buildings, and the shadows are the darker areas of this thing. So just from a logical standpoint, you could say, well, if the source of sound is 300 foot in the air and the building's like 350 foot or something, then the sound casts shadows on all opposite sides from the source. So that would be on this side, on the west side of Mandalay Bay, the south side of Mandalay Bay, and over here for the Tropicana, all the things which are on the northeast side. The Excalibur is fairly straightforward, or the portion that I have there, because the shadows, it gets shadows from this east-west wing on the north side. Now the pyramid's a little different because it has a slope to it, and this program doesn't simulate things very well. So what I did was I put in a series of 12 buildings here, each progressively higher and smaller in nature, and that generates this kind of odd shaped series of soundscape, shall we say. Alright, now some of the things that you'll notice on this is that there are, because the Mandalay Bay on the north wing is not flat, it's kind of a stub nose with three different angles, with three sides on it that are angled relative to each other. We get some penetration of louder sounds going west over towards the Delano. And similarly, the sound refracts around that flat edge and comes over here towards the convex side of the north and southeast wings. And that area gets pretty loud. In fact, you can see, if you follow it right from this little black cross down south and east, that there's a pretty strong region that hits the southeast wing and then gets reflected out east. And so there'll be a stronger set of sounds on that direction. Similarly, we have some weird shapes up here all over. And so, you know, all of a sudden we have to ask ourselves, well, how did these weird shapes get in there and what sound? Well, there's a simple little feature in this program. It's called array receiver, and if you put array receiver anywhere, it'll show you how it calculated the sounds. So for example, we put array receiver out here on the east side of the Mandalay Bay on the southeast wing, and we ask for rays and not waves, and the height, well, let's set it at 1 meter, which would be the ground level, and it'll show us what the predominant paths are for the rays. And here we can see that it has two propagation paths. One is directly from the source itself, and then the other is reflected off the southeast wing. And so this little ray tracing object becomes quite useful, because we want to know where some of these strange and weird formations up here come from. We can just drag that little gadget up there. Let's say we drag it way up there, and here we got a bunch of rays. So in this case we can see that we've got two sets of rays caused by diffraction come around the corner of the north wing, and they go straight up that way. And then we have a path that goes from the window out to the pyramid, reflects off, comes back over here to the southwest wing of the Mandalay Bay, reflects off over to that. And then we also have oh no, that's just a black line. So in that case we've got 1, 2, and 3 paths that add up to creating that little funky thing. Similarly, we could drag it over here closer to the Delano and look what was happening there. In that case, it's just pretty much straight refractive around the window. If we wanted to go over here, now I don't have a lot of the buildings in here, and as you add more buildings you get more reflective surfaces and of course more paths, and the model changes. So when we're down here near the entrance to the portico, or the entrance to the Mandalay Bay over here in this little convex region has a roof over it. It's 2 layers, and as we're entering the top layer we're going to get sound primarily directly from the window itself, but also reflected off the Excalibur way down here. So the sound comes out the window, bypasses the pyramid, if my model is correct here, and comes over to the Delano and comes back, and we receive both sounds, or pass from 2 sounds. Now the path that's small here from the window directly to our receiver is a very quick path, and so the other path going all the way down to the Excalibur and back would probably be on the order of seconds. I don't know how far it is. Let's see, this is a 500 meter scale, so that would be that's 500, 700 meters there, and probably 800, so 1500 meters, which is 4,000 feet, because it's 3 feet per meter, roughly speaking, times 1500. That's 4,500 feet, or almost a mile. But anyway, at a little over 1,000 feet per second for the speed of sound, that's going to take on the order of 3 to 4.5 seconds to get back there. And no doubt at that time that the power in that path will be pretty weak, so it may come back. It could add or subtract depending upon the phase of the waves. But anyway, it'll be pretty weak by comparison to this short and direct path. Similarly, the foundation room, which is up on top. Now I can't drag this thing exactly on top because it doesn't calculate on top of buildings. But if I drag it as close as I can, then we see it has the same exact thing as when we had it out a little bit further. We have a direct path coming around the building, diffracting around that and coming up to the top, but then we also have a possible path reflecting off of the Excalibur Hotel. So with this ray tracing, you can ask lots of different little questions, and some of the answers are pretty fascinating. So for example, if we were over here in the venue, just anywhere in particular, and we say, well, what are the sources of sounds? And you look, and so you drag that little receiver over there, and you can see that we've got 1, 2, 3, 4 sounds. Alright, well, what's the easiest one? The direct path. So the direct path is from the window and over the top of that little 1.5 meter barrier right to us. The other is from the window around the end of the barrier where it has the opening in it on the corner and comes to us. The other is on the other end. Now I don't know if there's actually an opening up there, but if there is, then this model would be correct, and the sound would diffract around that and come to us. But then there's also this path that comes out the window, hits this very edge of the Delano, and comes back and bypasses the pyramid and goes over the top of the 1.5 meter barrier there and then hits us. So as you can see, the number of possible paths for the sound to reach a person varies very dramatically from place to place, depending upon the objects that can be reflected and the objects that can block the sound. So for example, let's see if we drag it over here towards the this is probably on the road there just in front of the Tropicana. Again, you can see we have a couple different paths. We have the direct path, and then we have a very strong path that's comes from the source, hits the Tropicana and bounces back down into us, reflects back into us. In that case, those two paths are probably of a very similar intensity, and so the sound here from those two paths will probably be substantially louder than in other places. So if we're down here near the church, we're probably on the back side of the church, then you're probably going to be getting the same thing. We're going to get those same two strong paths, one direct and one off the Tropicana, and then some other little alterations from things refracting around the edges of the barriers or other buildings. And for this model, the total is 76.3 decibels, which is louder than your average conversation. Your average conversation varies from 40 to 60 decibels, and this is 15 decibels over that, which is on the order of 13 times greater than your conversation level. So the sound here is going to be pretty good. Not as loud as over here, which is that one has a real interesting see, I haven't played with this much, but this one has a fascinating. So over here in that field on the south side of the church, at this location we have a direct path there. We have a path that comes out over the barrier, hits the end of that Tropicana building, comes back, hits the Mandalay Bay, and then eventually makes it out to us. So that's a pretty complicated path. The intensity is going to be small, but it can all add up. And let's see, and then it has a path that goes out the window, hits the Delano and comes over there. And let's see, what other paths did it have there? It had one. Oh, and then it had another smaller path that refracted around one of those VIP sections. So there's a small component that refracted around the VIP section to get to us. So, you can answer with, for example, this model. You can answer a lot of. You can get a good idea as to where the source of the sound is, which sometimes is hard to figure out just thinking about it, because there's a lot of reflective surfaces to deal with. And I thought I'd just share that with you. Now, someone asked me to do a little experiment, and so I did, and I did it in spades. And so let's just turn this off for the moment, turn off that receiver. And they asked me to raise the elevation of the source of this emitter here to 500 feet, which is about 165 meters. We'll keep, for the moment, we'll keep the intensity the same. But when we do, and it's going to be calculating it here so we can talk while it's calculating it, we'll see what happens if the source of the sound was above the Mandalay Bay. Now, in general, I know it's not, because I've gone through all this analysis. But early on in the game, we could have asked this question, and we could have said, well, what does the sound look like if the source of the shooter is above the hotel? And as you can see, in many cases, it's a little similar, but in many other cases, it's not. So, for example, the reflection pattern from this wing of the Mandalay Bay is not as great or pointed out this way. It sort of points back over this direction. We don't get these weird patterns up there, but mostly shadows on this side, but not too many shadows either here or here. The shadow up here from the Luxor is narrowed. In fact, all the shadows are more defined and smaller, and the reason for that is because with the higher elevation, there are fewer places to hide. In fact, and so we can see here. Now let's turn on our little receiver and see what paths we have this time. Just on the rays. It still has a very similar set of paths. Yeah, so we still have the reflection there. So the buildings didn't change, even though the source got higher. The paths didn't change that much. This one moved over a little bit. And these don't quite... Well, I have to go back and read my legend to see how strong. I think the longer lines indicate lower frequency and or lower intensity, and the small dotted ones indicate higher frequency paths and higher intensity. So let's see, let's drag it back over to the foundation room, close as we can get. And in that case, it didn't do too well. I've got it on top of the building, that's why. There we go. Still says we have a similar set of paths. One direct that refracts around the building, one that comes straight to it from the source, and then one that reflects off the Excalibur. But up here, so we no longer get reflections off this wing or off the Delano. Now it's off the Excalibur, off the Luxor, excuse me, and the direct refractive one. So it does change for some locations. And in the venue, let's see, what do we get? We still get the effect of the Tropicana over there. Now, if we were to put on that side there, that's interesting. For this 500-foot elevation shooting, if we're on the boulevard side of that little building that encompasses the fountains in front of Mandalay Bay, we've got a bunch of different paths here. The strongest one appears to be something that comes from the source that's above the hotel, goes out to this little piece of the Tropicana that's higher than this section, and then comes back. We then have one that's less. Oh, I'm sorry. These longer lines are not as intense as these. So the most intense ones are directly from the source over the top of the building or around the edges. The next strongest one is probably, it's either that one or that one, but this one path up here is pretty interesting. Out the window, reflects off the Luxor, reflects off the Excalibur and then comes back to us. So you can see it's not always a simple, straightforward line of sight um, situation that determines how loud the signal is that you're receiving. And with so many reflective surfaces in Vegas, there's very few places to hide except behind extremely tall buildings. And that's for a source at 500 feet. Now, let's take that source, which is the black one, and if we move, well, let's do another little experiment. Let's turn the room 32-135 off, and then let's take some people thought that there were helicopters between the Delano and the Mandalay Bay that could be seen from the venue. So let's put a transmitter there, a source. Let's put it at 165 feet, 165 meters rather, 500 feet, 165 meters, 500 feet. Now in this case, I'm going to model it as a gun that's very loud, 20 decibels louder than coming out the window, with no suppressor on it. So in this case, you've got let's say a helicopter, just for giggles, with a guy hanging with his gun out the window, so with no suppressor on it, and so all of the sound from the rifle is coming out, and it comes out at about, I reckon, about 160 decibels. This is for the muzzle blast, so it's a really loud thing. So if you had that situation, oh, did I turn it on? I think I turned it on. Maybe not. Nope, didn't turn it on. Okay. If we had that situation, that really loud gun hanging out there, and I have to put it in a little bit, well, we can leave it there. Let's put it in a little bit better position so they get more of the shots coming out, sound coming out towards the venue. And let's turn that thing off for the moment. We just want to see what it looks like. Okay, so the pattern of sound that gets generated for a helicopter between the Delano and the Mandalay, operating at stationary position 500 feet above the ground, with a loud gun hanging out the window that's not suppressed, would be this. And you'll notice that there's regions of yellow everywhere and massive regions of red. So what this says, that if you had that scenario, then these two sides of the Mandalay Bay and that side and these two sides of the Delano would have been inundated with gunshot sounds that nobody could ignore. So you would have gotten reports from all of these sides of these windows. Now, in general, the loudness of the sounds, because the rifle is 20 decibels higher than coming out the window, goes much further, as indicated by all the yellow regions. Even though that with these tall buildings here that aren't as tall as the source, you still have some interesting shading going on, and this will take a while to get to a 4 meter grid, which will give us a better definition. So you see, with that type of elevation and that type of power from that rifle, there are very few places where the gunshot sounds just wouldn't knock you off your feet level. Now that perhaps is not a very realistic model. Perhaps it should be less in intensity, and perhaps the ground should be less reflective, all sorts of things. But it shows you the big difference between a gun that is completely exposed and one that's backed off in the room and is 20 decibels lower in intensity. And remember, 20 decibels is 2 bells, which is 10 to the power of 2, which is 100 times less energy. That's a big difference. And even though it is a big difference, 140 decibels is still, up to your next to your ear is still going to cause them to bleed. So imagine what 160 decibel next to your ear is going to do. And that's why people wear protection on their ears. So that one was just kind of, for shits and giggles. And if we now turn on that ray receiver here, and we'll try to see for that position. Yeah, see, we don't get the left path over here, and we get a slightly different reflective path. Let's go out here to the venue and see what's happening. And for that position, we don't get anything coming from the far end and coming around it, and so it's a little bit simpler case. Now, what about over here on the street in front of the Tropicana? Yeah, once again, most of the paths are direct and don't involve these ends of the barriers, but it does involve that end of the barrier. And it's kind of interesting that here the sound comes out the side of the helicopter, goes over and hits the southwest wing, bounces almost directly back, which means that it probably is obscured by the helicopter itself a little bit, comes over to the Delano, hits that small edge, comes out, goes all the way down to where you're receiving. And of course another path is from the helicopter to that lower building from the Tropicana and then to you. So, and this results in a total of 88.2 decibels. So between here, where there's 112 or better, to there is again, a little bit more than 20 decibels. And if we were to change how reflective the ground is and all that, we'd get a slightly different number. But let's do that. Let's change it to a oops, wrong, little, I want that gear. Let's change it to 0.5 and see how much of a difference. We were at 0.3, we'll change it to 0.5, and we'll see how much of a difference if the ground absorbs more of the energy, that will be for this scenario. It only dropped it for that one location, about 3 or 4 decibels. So it didn't change it that much. Why? Because it's an elevated position and it doesn't go across the ground that much. If it had been a shooter at the ground level, that would have just dramatically changed things. And I've never even tried it. What if that shooting position was only 15 meters? That's would be an interesting. So that's 45 feet in the air. What do the patterns look like? Now, that's just unrealistic because obviously you can't have a helicopter flying 40 feet in the air, which is right on top of the roof of that building that is between the two. In this case, we went up again, so it made it louder over there with a lot more loudness in between. I mean, anybody standing on the ground next to that helicopter is just going to get blown away by the sound. Oh, look at this, we got a lot because now we're below the height of these buildings, then the shadows become much more pronounced. And this would have, if you don't want to presume that there was a helicopter there, just think about a shooter on top of that roof for the buildings that connect the Delano to the Mandalay Bay, and this would be the scenario. And even, which would mean that anybody in those taxis there wouldn't receive much of a signal at all, and we know that they just receive a very intense signal, so the shooter is not on the other side of the building. Plus, if he were, all these people in all these suites would be bitching and moaning about a shooter right outside their window. At least I think they would. Okay, so with this tool you can do fun games, but if you have a question about, where the sound is coming from, you can just drag that and it'll show you. So in this case we got a path that somehow manages to go over the building. So it's going to be a very weak uh, contribution. And then we got one that goes around this side of it. Oh, in this case, the model was flawed a little bit because it snuck through between those two. I modeled the building with two different pieces, so it somehow snuck between them. And then we have the reflection. Now, what's this way over here? What's this weird thing? How'd it get there? Oh, you see? Isn't that fascinating? From the source of the shooter, which is 45 feet above the ground, the sound comes out, bypasses the Luxor, and then hits this little bitty end of the Tropicana at the lower level, and then reflects out that way, and that's what caused this spike in sound. And what caused the spike over here, the green, which is louder than the light blue. No, just pretty much straight up and over, and that little flaw in the model. So this is not a technically accurate situation, but it is an aid in helping understand what might be going on with these various locations and all that. All right. Well, I think that's enough about this. I'll continue to play around with different aspects of this model. If you have more questions, leave them in the comments, and we'll grab you in the next one.